Hi guys, welcome back. So today we are gonna finish our unit on rational exponents. Before I forget, I wanted to point out the following. Just because we have rational exponents, it doesn't mean that our answer has to be written in radical simplified form. Pretty much we just have to follow the directions. If the directions say write your answer in radical simplified form, then if you have a rational exponent, guess what? You write your answer in a radical form. But if the directions say leave your answer in exponential form or fix it so your exponents are positive, then that's code for if you have a rational exponent, then leave it in exponential form. Okay, so let's do this. So the directions read simplify each expression, write answers with positive exponents only, leave answers. Oh, and I guess to clarify, what does that mean? Leave answers in exponential form, do not write answers in radical form. And then my favorite disclaimer, assume all variables represent positive real numbers. I love this statement because that way we don't have to worry about do I need an absolute value or not. Okay, so let's do this. So for problem A, we have w raised to the 5/8 and we got to multiply it to this addition problem, or we got to distribute. So let's go ahead and do this. So we have this w multiplied by the first term. So let me go ahead, zoom in. So then I'm like, whoa, what's the product of the w's? I forget. If the exponents were whole numbers, I think it's a little bit easier for me to digest. But the fact that we have rational exponents, it just puts me out of my comfort zone. So I'm like, what do I do with the exponents? Oh, I'm so frustrated. I'm so mad. Okay, so I'm like, silly exponent rules, they make me so mad. And if you have no idea why I'm venting my frustrations, I'm crying because that means you didn't watch my earlier video from an earlier chapter where we had talked about exponent rules. Okay, so I'm like, silly exponent rules that make me so mad. So my frustration is meant to remind me that if I have a multiplication problem, we're going to keep the base and add the exponents. Keep the base and add the exponents. So let's do this. So product of w and this 3w will give us 3. I didn't say the exponents purposely. And then product of the w's, okay? When we're multiplying two things that have the same base, we're going to keep the base and add the exponents. So the base is w, and for me it's a little bit hard to add the rational exponents on my head. So guess what? I'm showing all my work. Okay, so we're going to keep the base and then add the exponents. Sorry, I'm trying to zoom in. Okay, that's as big as I can get. We're going to keep the base and add the exponents. So the exponents are 5/8 and 5/8. Okay, one product down, one more to go. Okay, next product. Okay, sorry, I was bombarded with a spammy call. Okay, so one product down, one more to go. So let's go ahead, continue to distribute. So factor times the next thing that we see. Product of this w and this 5w will give us 5. I don't say the rational exponents because they take me a while, okay? So product of the w's. Remember, when you're multiplying two things that have the same base, when you have a multiplication problem, if you're multiplying two things that have the same base, you're going to keep the base and add the exponents. So the product of the w's, we're going to keep that base of w. And then we will add the exponents. So 5/8 plus 11/8. I know you can add in your head, but I can't. So I'm going to show my work. Okay, so we're going to keep the base and then add the exponents. 5/8 plus 11/8. Okay, so let's go ahead, take our time, and then simplify those exponents. Okay, the sum of 5/8 and 5/8. You know what? I'll take the gift of having the same denominator. 5/8 plus 5/8. We're going to add the numerators and write the sum over the common denominator. So the sum of the numerators will give us 10. And then we're going to write that over its common denominator. The next one, plus 5 times w raised to, again, I'll take the gift of the rational exponents having the same denominator. So let's go ahead and add. So we're going to add the numerators and then write the sum over the common denominator. Sum of 5 and 11 will give us 16, and then we'll write that sum over the common denominator. So that's our answer. But when it comes to fractions, whether it's a straight fraction or a rational exponent, it's implied that we always reduce. 10 and 8 have a common factor of 2. So when we reduce by 2, whether you old school reduce, meaning you show me what you reduce by, or you use your cross-casting notation, we will tell the world that 10/8 reduces to 5/4. So that will give us 3 times w raised to the 5/4 plus 5 times w raised to, and lucky for us, quotient of 16 and 8 gives us the clean integer of 2. So we simplified the expression. So simplify is code for clear grouping symbols and then combine like terms as you see fit. So we cleared the grouping symbols, but now the question is, can we combine like terms? And the answer is no. Okay, we couldn't combine them from the start, so we're not going to combine them at the end if we multiply by the same thing. But if you're feeling a little bit nervous, it doesn't hurt to take a second look. So both of these terms have w's, but remember, like terms means same variable, same exponent. So we don't have the same exponent, so they're not like terms. And just like that, we have simplified the expression. We are going to do a total of 4 problems. That is our first problem. Let's go ahead and knock out 3 more. So problem B, we have x to the 3/4 over x to the 1/6. Okay, so the directions just read simplify each expression. Okay, so in this case our expression is a fraction, and when it comes to simplifying fractions, that's just code for reduce it. So I'm gonna ask myself, is this bad boy reduced? And the answer is no. Why not? Because we have variables in the top and the bottom, so we need to cancel some x's. So then I'm like, how do I fix it? When I have a division problem, I'm so frustrated. So I'm like, silly exponent rules, they make me so mad. And then I'm quickly reminded that if we have a division problem, we're going to keep the base and subtract the exponents. Keep the base and subtract the exponents. Which exponent should you subtract? Well, it just depends by which factor of x you are dividing. Ideally, you would like to subtract the smaller exponent, but in case you ideally we will want to subtract the smaller exponent to avoid having a negative exponent in the answer. But you don't really have to worry about that. If for some reason you end up with a negative exponent, then just fix it so it's positive. Okay, so in this case, I believe 1/6 is smaller than 3/4, so we're gonna divide top and bottom by x to the 1/6. And in case I end up with the negative exponent by mistake, it's okay, I'll fix it. Okay, so we're gonna go ahead reduce by dividing top and bottom by dividing. Okay, by dividing top and bottom by x to the 1/6. X to the 1/6 goes into itself once, and into our top factor, I don't know. Okay, but I know that we're gonna keep the base and subtract the exponents. So I'm gonna put minus 1/6. Okay, so whatever the difference of 3/4 and 1/6 is, that will be the exponent in our answer. So that leaves us with x raised to the 3/4 minus 1/6. So for me, it's really hard to subtract in my head. So I'm going to go ahead and bust out a thinking area. So what is a thinking area? So a thinking area is exactly what it sounds like. It's an area where I think. Okay, so we have 3/4 minus 1/6. I highly discourage students from doing from doing scratch work on a separate sheet of paper, because I don't know how many times as you're looking through your notes, you're like, where is my sheet of scratch paper? I need it. But if you do your scratch work on the same paper, you will never be in that situation where you can't find your scratch work. Okay, so let's go ahead, take our time, find the LCD. The least common denominator between 6 and 4 is 12, and then we're going to take our time to write those equivalent fractions. This 4, to make it look like our common denominator, let's give it a 3, but we need to have good notation, so top and bottom by 3. So we're going to tell the world that 3/4 is the same as 9/12. Minus, to make that 6 look like a winner, let's give it the missing factor of 2. But again, we have to have good notation, so we're going to multiply top and bottom by 2. Okay, so when we do, we're going to tell the world that 1/6 is the same as 2/12. Fantastic. When we keep our cool, now that the denominators are the same, we have green light to subtract. Difference of 9 and 2 is 7. Sorry, I was having a moment. And then we write that difference over the common denominator. So let's go ahead and transpose our solution. So that will give us x raised to the 7/12. So remember, whenever we have a rational exponent, that is code for getting radical. But bear in mind that the directions say that we are to leave our answers in exponential form. Okay, so don't be an overachiever and write it in radical form. Okay, problem C. So remember, we're doing 4 problems. This is our second problem. Let's go ahead and write the third one. Okay. Let me zoom out. Okay, so I'll write the letter C and then see if we can see it together. So yeah, we can. Okay. So letter C, where am I? We have x to the 1/5 times y to the 2/3. That product raised to the 15th power, and then we're going to divide that by x squared. Cool. All right. So yes, we have a fraction. Yes, we want to make sure it's reduced. But before we can think about what we can reduce by, we got to make sure that both the numerator and denominator are simplified. So for the numerator, we have a product of 2 factors, and then we're going to raise it to the 15th power. So I got to remind myself, what is that power rule for exponents? My frustration is not going to save me, because my frustration only helps if we have a multiplication problem or a division problem. It doesn't help with the power rule, so I have to remind myself. So for the power rule says this: if we have a factor and you raise it to some power, how are you going to handle it? You're going to keep the base and multiply the exponents. So notice that when I wrote out the formula, I didn't say, oh, x to the n raised to the nth power equals x to the m times n. No, who can memorize things like that? Okay, I can't, at least. For me, it's so much easier to memorize formulas by just saying the words. If I have a factor and I raise it to some power, how am I going to handle it? Oh, I'm going to keep the base and multiply the exponents. And then I write the variables as I go. Okay, so let's go ahead and clean up the numerator. So remember, the power rule only carries over to factors, whether it's a single factor, product of factors, or quotient of factors. So let's do this. First factor raised to the 15th power, how are we going to handle it? Power rule, we're going to keep the base, which is x to the 1/5. Sorry, I said it wrong. Sorry. Power rule, how are we going to handle it? We're going to keep the base of x, and then we're going to multiply the exponent. So it's 1/5 times 15. Okay, sorry for saying that incorrectly. All right, one factor down, one more to go. This y, okay, y to the 2/3, when we raise it to the 15th power, how are we going to handle it? We're going to keep the base and multiply the exponents. So the base is y, and then we take our time to multiply the exponents. And that's all over the denominator. All right, so let's go ahead, clean up the top, and then confirm that our fraction is reduced. Or if it's not, then we reduce it. Product of 1/5 and 15, 5 goes into 15 3 times. And that will leave us with x to the 3rd power. Okay, times y raised to some power. Product of 2/3 and 15. Well, 3 goes into 15 5 times, and that will leave us with 10. So times y raised to the 10th power all over x squared. So we did it, okay? So we have our fraction. Now we have to ask ourselves, is our answer reduced? And in this case, the answer is no, because we have x's in the top and x's in the bottom. So let's go ahead, reduce. And if you need the reminder, go ahead, vent out your frustrations, and then you will be quickly reminded that whenever you have a division problem, you're going to keep the base and subtract the exponent. So in this case, we're going to divide by x squared. So let's go ahead, subtract by 2. X squared goes into itself once, and into x to the 3rd. We're going to go ahead, subtract that exponent, and that will leave us with 1 factor of x. So let's bring down what we have. In the numerator, we have a factor of x times 10 factors of y. That's all over 1, but it's not needed to write it over 1. Okay, so we have some exponents in our answer. They're all positive, so we're good. Okay, so I told you that we were going to do 4 problems. This is our 3rd one, so I'm going to hunt my 4th problem, and then we'll wrap it up. Thanks. Alright guys, so our 4th and final problem has been located, so let's do this. There's different ways that you can approach this problem, but this is how we're going to do it. If you decided to attack it differently, it's fine. Signs will cancel and we'll get the same answer, I promise. Okay, so first things first, we think of order of operations. Order of operations, we're going to attack the grouping symbols. The first set of grouping symbols, we have this fraction right here. When it comes to fractions, what do? We simplify them. In this case, it's already simplified in the sense that it's already reduced. But you know what? I'm having a moment that the exponents are not positive, okay? So you can either make them positive now or you can make them later. It's up to you. We're going to make them positive now. We're going to make them positive now so that way we can start on a good note, okay? So remember, for the negative exponent, to make the exponent positive, you're going to move the factor about the other side of the fraction bar. So in this case, we're going to make this top exponent positive, we're going to move the factor to the other side. In this case, bring it down. For that other exponent, to make it positive, we're going to move the factor to the other side of the fraction bar. So in this case, bring it up. Okay, so let's do this. So the top comes to the bottom. Oh, sorry, make it positive. Okay, I got a little bit nervous. Okay, and then the bottom one, okay, we also have to move it. Why? Because it has a negative exponent. So we move it to the other side. And anytime we move a factor to the other side, we switch out the exponent. Cool. All right. So again, it was already simplified in the sense that it's reduced, but I just wanted to fix it so all the exponents were positive. Okay. Then what's going on with this fraction? It's being raised to the fourth power. And then you can continue to work your magic now or later. It's really a personal choice. I think I'm just going to bring down the rest of the problem. So times m raised to the negative 3/8 times a raised to the 1/2, and that product will be raised to the negative 1/2. Okay, cool. So now at this point, let's go ahead and apply the power rule to clean this up. So remember, friendly reminder, power rule, if you have a factor and you raise it to some power, how are you going to handle it? So to clean it up, you're going to keep the base and multiply the exponent. So it doesn't hurt to remind ourselves. So we have a fraction, we're raising it to some power, we're just going to apply the power rule to the numerator, and then we'll apply the power rule to the denominator. So let's do this. Power rule to the top, power rule, keep the base, and then multiply the exponent. So it'll be 3/4 times 4, okay, over, okay, power rule to the bottom, okay, keep the base of m, power rule, okay, raising powers, you're going to keep the base and multiply the exponent. So the product, when we multiply, it's 1/3 times 4. I know you're awesome and you can multiply in your head, but I really can't. So this is why I show all my work, okay? So times, okay, this product raised to some power. Let's apply the power rule again. Power rule, okay, you're going to keep the base and multiply the exponents. So we have the first base is m. We're going to raise it to the negative 1/2. So we're going to keep the base and multiply the exponent. So it's negative 3/8 times negative 1/2. Apply the power rule to the second factor. Power rule, keep the base, multiply the exponents. So I'm not going to lie, this is a little bit visually overwhelming, but it is what it is. So let's clean it up and then we'll finish it off, okay? Product of 3/4 and 4 will give us 3. So that will leave us with a to the third over product of 1/3 and 4 will give us 4/3 over m raised to the 4/3. Cool. All right, or 4/3, how normal people speak. Times, let's clean up this now. Next product. Can I cancel things out? I believe the answer is no. Okay, so times m raised to positive something. 3/8 times 1/2 will give us 3/16. Times product of 1/2 and negative 1/2 is negative 1/4 times a raised to the negative 1/4. So if I was on it, I would be like, bam, cancel out. But you know what? This problem is really out of my comfort zone. So with your permission, we're just going to multiply across and then reduce at the end. Okay, so we have a times m times this other a. So let's go ahead, multiply together, and then simplify at the end. So we have a cubed times m raised to the 3/16 times a raised to the negative 1/4. Okay, when we're multiplying variables, we typically don't separate it by the raised dot, but I think I'm going to put the raised dot because I need that separation for me, not for credit. Okay, and that's all over just that one denominator because it's not being multiplied by anything else. Okay, Now that we have all the factors housed under one fraction, it's going to be a little bit easier for me to attack it. Okay, so let's go ahead and do this. We multiply whatever we can, cancel out whatever we can. Okay, product of the a's, a cubed times a to the negative 1/4. I know you're on it, but I'm not, so I'm going to speak to myself because I love myself and I hope you do too. Okay, so let's go ahead and multiply the a's. And now what I'm going to do, I'm going to write them side by side so that way it's a little bit easier to see where my next step came from. Okay, so let's multiply those a's just by putting them side by side, and then we'll simplify the product. So we have a cubed times a to the negative 1/4 times m raised to the 3/16. So again, the raised dots are optional because we have product of variables, but I need that separator. All over m raised to the 4/3. Okay, fantastic. So let's go ahead, take our time and simplify the product of the a's. So remember, when it comes to multiplying two things that have the same base, let's vent out our frustration. When it comes to multiplying two things that have the same base, you're going to keep the base and add the exponents. Okay, multiplication problem, keep the base and add the exponents. So we're going to keep the base of a, and then we're going to add the exponents, which is 3 plus negative 1/4. Okay, we take our time. I think that gives us 2 3/4. Okay, but I'll show my work in a bit. Okay, times m raised to the 3/16, and that's all over m raised to the 4/3. Fantastic. So I'm going to go ahead, bust out a thinking area to add these two right here. Okay, so we have 3 plus negative 1/4, which is the same as 3 minus 1/4. We write the LCD and then write those equivalent fractions. There's only one denominator, so that is that LCD. Let's take our time, write those equivalent fractions. 3, we're going to write it as 3 over 1. 1, to make it look like a winner, let's multiply it by 4. But you know the drill. You got to multiply top and bottom by 4. And then we'll tell the world, 3 is the same as 12 over 4. So let's do this. So that will give us 12/4 minus 1/4, and last time I checked, difference of 12 and 1 is 11, and then we're going to write that difference over the common denominator, namely 4. Okay, so that's for the exponent on a. Okay, so that will leave us with a raised to the 3 plus negative 1/4. Our work shows that that sum gives us 11/4 times m raised to the 3/16 all over m raised to the 4/3. I'm not a fan of writing the fractions by using the slash, but sometimes I don't have enough space, so I have no choice. Okay, so that is our answer. All the exponents are positive, so we're good. But now the question is this bad word reduced? And the answer is no. Okay, it's not reduced because the top and bottom has some m's. So when it comes to division, let me vent out my frustration. Silly exponent rules that make me so mad. If we have a division problem, how are we going to handle it? Okay, we're going to keep the base and subtract the exponents. Again, it doesn't matter by what you divide by. The worst thing that could happen is that you'll have a negative exponent. But if you can avoid having a negative exponent, why not? So we're going to look at the smaller exponent. So it's like 3/16 and 4/3. Well, 3/16 is a fraction under 1. 4/3 is a fraction over 1. So I guess 3/16 is the smaller exponent. But again, subtract whatever you want. And if you have a negative exponent, then just do what we did earlier. Move the factor to the other side. Okay. So let's go ahead, divide or reduce by m to the 3/16. This goes into itself once, into the other factor of m. How do we handle it when we divide? We're going to keep the base and subtract the exponents. Okay, so that leaves us with some a's on the top, a raised to the 11/4 over some m's in the bottom, m raised to the 4/3 minus 3/16. Okay, remind me to put like the exponents first, because that way I can have more space. Okay, so let's take our time and then see what the difference of 4/3 and 3/16 gives us. I know you can do it in your head, but you know the speech, I can't. Okay, so I'm going to show the work. Okay, least common denominator, in this case it's what is it, 48. Cool. All right, if you're having a moment finding the LCD, I need you to reach out to me, and then we can do a one-on-one session. Okay, so let's do this. This 3, to make it look like 48, let's go ahead, give it the missing factor of 16. And that will give us that 4/3 is the same as 424. 24, not 24, 64. I should just use the calculator, right? But I'm trying to impress you. Okay, cool. All right. So 16 times 4 is 64, and that's over 48. Minus 16 to make it look like a winner. Let's give it the missing factor of 3. And then we will tell the world that 3/16 is the same as 9/48. So let's take our time, do what we gotta do. 64 minus 9 gives us 55. We're going to subtract the numerators and write the difference over the common denominator. Fantastic. So our fraction is reduced, so we're good. It's an improper fraction, but just leave it as such. Okay. So in the numerator, I don't have space. Okay. We still have the same number of a's, a raised to the 11/4 over the denominator. Thanks to your hard work, the denominator simplifies to m raised to the 55 over 48. I'm going to box it and then say a couple of words. So the question is that our answer? Of course it is. That's why I boxed it, okay? But things to watch out for. Are the exponents positive? They sure are. Is my answer reduced? Yes. Why, or how can I tell? Because it's reduced because we don't have a's to cancel and we don't have m's to cancel. Okay, guys, so I said we were going to do 4 problems. This was our 4th and final problem. So we're out. Thanks.